Good afternoon, ladies and gentlemen. I hope you're having a good conference. My name is Bruce Hall. I work for ONYX Insight, and we are a company that does predictive analytics. Now, the title of our journey is a journey through 16,000 turbines in this O&M evolution or revolution, as you may want to call it. We haven't got long, so I'm just going to take 60 seconds to introduce ONYX Insight, if I may. Well, who are we? We are a predictive analytics company totally focused on the wind sector. You can see a picture of the globe here from left to right, from the US all the way across to Asia Pacific, and a little pie chart just indicating how much business that we do in these various countries. A relatively small country with a good exposure all the way across, but we also do a lot of work here in India, of which we're very, very proud. And the range of customers that we work with, 7 out of 10 of the major operators around the world work with us, including some Indian companies, which you can see on that list. And what do? Well, we do 3 main things. We do predictive analytics. We take data off wind turbines. We analyze it, we play it back to our customers and help them make the best maintenance or production decisions. The second thing we do is we sell sensors. Various sensor types that depending on what type of customer problem we are experiencing. And I'll talk about it a little bit later, as the turbines evolve, new failure modes occur, and sometimes those new failure modes need new sensor types, and we work with our customers to do that. And thirdly, we have an engineering and consultancy team that go out onshore and offshore and work with our customers, again, if we discover a problem with them. Anyway, enough about us. Let's talk about the technology evolution, and it's a truly fascinating topic. So we're talking here about using data to improve efficiency. And I don't know what it's like here in India. I'm not an expert on the Indian market, but when we work with our customers around the world, what they are pretty much saying to us is there is an abundance of data. There's almost too much data that they're getting. Various different sensor types, which it could be CMS systems, it could be SCADA systems, it could be oil systems, oil analytic systems, acoustic systems, a whole range. To some extent, some of our customers feel like they are bombarded with data. And you can put that data, its aims, into 2 main buckets. One is it's going to improve reliability, maintenance, or secondarily, it's going to improve production. But a key question, if we were to ask our customers anywhere around the world, and I'm pretty sure this is the case in India as well, is what we're finding is, so I don't want to point the laser in this gentleman's direction here, in the red area, how do I make the best decisions? What is the best decision based upon the data that I'm getting from my systems? And that's the dilemma, ladies and gentlemen, that we face with our customers. Yes, there's lots of data, but moving from data to insights to the correct decisions is fundamental. The case is fairly clear, though, with regard to data and data analytics, the benefit that it can have. And there are 2 charts I wanted to show to you. The one on the left is the yellow bar chart. So on the yellow bar chart, you've got the cost per megawatt hour of O&M costs versus maintenance costs. And then you've got the 3 maintenance strategies. You've got OEM, you've got hybrid, and you've got in-house. And what we're seeing is there's this constant trend moving away primarily from OEM full wrap towards in-house or a hybrid structure at least. And the customers that we've worked with in India, this is a particular India case study that we've got, by moving in-house or moving to hybrid, you can save approximately 40% of your O&M costs. And again, that's a proven case study. On the right-hand side, you can see people's attitudes to this around the world. And what the green bar chart on the right shows, if we speak to our key customers and we look at what is their prediction of OEM market share over time, the right-hand side is saying more likely than not that the OEM share will decline over time. And why is that? It's nothing to do with the OEMs, of course. This is purely driven by cost efficiency and flexibility, the response. The customers want to be able to respond to their operations more closely. And if I was to build upon that case study still further, again, this is a case study that came from ONYX. Even in-house is an opportunity through smart maintenance through accurate decision making using quality data to take another 15% out. And those case studies are well spoken about. We can share them with you if you wish. And that comes from improved diagnostics, as in when am I going to have to do a major corrective, all the way through to moving from scheduled maintenance rather than scheduled maintenance to condition-based maintenance. It could be optimized purchasing, et cetera, et cetera. There are various ways of doing it, and the case is well proven. And as I conclude on this part of it, is that whether it be here in India or whether it be anywhere else around the world, this is a proven way forward. Moving from standard maintenance to reliability-centered maintenance yields thousands of dollars worth of saving per turbine per year. But that's what we know right now, ladies and gentlemen. There's one chart that you may have seen before. This is a particular favorite of mine, but this kind of shows the future. And what you've got here is a plot of the cumulative failure rate on the vertical axis over time. And what that shows in the yellow bar, the yellow line, it shows you what failures were predicted from year 0 through to year 20 of that turbine. And you can see the yellow line is the forecast. And then in the black lines, you've got the forecast. P50 means it was 50% of accuracy. 10% of accuracy was at the high end. Well, what that is showing is at around about year 10, which I'm told is the average age of a turbine here in India, that's when the two lines start to deviate. And at that point, different failure modes are starting to be experienced. And that's because some of the failure modes at design stage couldn't be fully forecast. So one message I would leave with the India team here, and the ONYX, please do speak to the ONYX team here, is as India passes this 10-year milestone for its average age of turbine, the issue about unscheduled failures, unforecast failures, may become more and more prevalent. That's certainly what we've seen in the market. Now, what does that mean? It means the opportunity to innovate and use data more innovatively becomes more and more important. So that's one side of it. I've talked about maintenance. The second part, obviously, and I'm speaking to a room of experts, is loss of production. And if you look at the data from loss production, you can see here that these are the major component, the contribution of those major components to production failure. And that goes from blade, pitch systems, all the way through to scheduled maintenance and miscellaneous. There's one main component that is instrumented right now, and that is the gearbox system. But what this means is, that means 89% of your assets out there, or components, are unmonitored. And therefore, the capacity for those to contribute to loss production is quite significant. And again, we've got case studies of this. This is a particular case study with a very simple sensor malfunction. And many of you will have seen similar examples before. But again, it's getting under the skin of the data and looking at it. So here we have a chart on the left-hand side that shows a cumulative energy loss over time for a particular turbine. And when you map that against a heat map of turbines across time, you've got a heat map here. So blue means good, basically low shutdown rates, but red is bad. And there are various ways you can do this analysis. Sometimes it works, sometimes it doesn't. If it's purely theoretical, it's not going to add an awful lot of value. But put in the hands of people who know what they're doing, it can add significant value. And you can see here there are two particular turbines, I don't know which numbers they are, out of the turbines here, where a simple anemometer failure, a misalignment, was causing lost production. It kept on tripping the turbine unnecessarily, and it just needed to be corrected. But again, that boils down to a need for an understanding of the data. So as I come to the end of this short presentation, what I'm saying here is ONYX, or companies like ourselves, using advanced analytics, can identify and correct both reliability and lost energy risks. And this comes across the board from whether it be drivetrain, oil systems, very interesting talk given previously from the gentleman of Shell, showing what could be done there. It could be to do with pitch systems, a very hot topic right now, and also blades. There's a lot of talk about blade and blade failure and blade fault detection. But again, this is a new area that's emerging. Ladies and gentlemen, I'm coming to the very end of my presentation. So in the time I've got, I say it's been a great pleasure to be here at Windergy. Great pleasure and privilege to be in front of you. I would say as far as India is concerned, as India becomes a renewable superpower going forward, this issue about leading the way in O&M and O&M innovation going forward is going to be fundamental. And if we, or companies like ourselves at ONYX, can help you, please do let us know. Meanwhile, I wish you a very good rest of conference. Thank you very much.
Okay, so they are in Hall A. Any further information you seek, you can. May I request Mr. Bruce Halls if you can be on the stage, and I would like to request Mr. K.R. Nair to please join us in presenting the memento to Mr. Bruce Hall. So if you can join us back on the stage. Thank you.